All right, guys, today we are going to start our last unit. And our last unit is involving something that you may or may not have a lot of experience with. So far, we've done a lot with solving linear equations, graphing linear equations, so getting straight lines, linear inequalities, linear systems of equations, systems of inequalities, all that good stuff. So lots of linear stuff so far. Lots of linear stuff, whether it's equations or inequalities, systems or just single ones. We've done a lot with that. And for a lot of you, you've seen a lot of that stuff in past math classes. One topic, though, that you might not be as familiar with is how we're going to finish up our year. And we're going to be working with absolute value for our entire last unit. We're going to graph it. And we're going to solve absolute value equations as well. So we're going to start with the graphing piece. Because then the graphing piece is going to help us with the solving piece. So the first question I want to start with today is, and you might have a little bit of experience with this, what the heck does absolute value actually mean? Is the question. What does absolute value mean? If you need a little jog of the memory, absolute value, you can kind of see it down below in a couple places. It's where we have those two vertical bars. So if I were to ask you what absolute value means, does anybody know? Now I know we've heard of absolute value before. You worked with it a little bit at some point before now. Absolute value is the distance a number is from 0 on a number line. So we're talking about the distance a number is from 0 on a number line. There's other ways to define it too, but I think this one is the simplest. We've worked with number lines a bunch with our inequalities, so we're all pretty familiar with that. Now the key, you're thinking, Miss Golly, why do we need to define it? Well, we haven't worked with absolute value all year. And for some of you, you might only have a little bit of practice with it. So the reason why I want to define it as a distance, whether I'm moving forwards or I'm moving backwards, if I'm measuring a distance, whether the car is in drive or the car is in reverse, distance is always positive. Distance is always positive, whether I'm running forwards or running backwards. If I run a mile, I run a mile. Running a mile backwards would be very tough. But it doesn't matter which way I'm running it, it still measures as a mile, a positive mile. So for example, if we're talking it's the distance we are from 0 on a number line. Just a little tiny number line here. What if I asked you for the absolute value of the number 2? So in other words, how far away from 0 is 2? How many spots? 2. Okay, so in turn, let's go to the other side of the number line. What's the absolute value of negative 2? Or in other words, how far away from 0 is negative 2? It's 2. So notice positive 2 and negative 2, they have the same absolute value. So notice absolute value doesn't mean I just changed the sign. Positive 2 stayed positive 2. Negative 2 became positive 2. So the result of finding the absolute value of a number, it's always going to be positive. It's not the opposite sign, it's positive. It's how far I am from 0. So that should be, I'm hoping, just kind of that little refresher on absolute value. Hopefully like, oh yeah, I'm starting to remember those vertical bars and something about it always being positive. The first piece I want us to look at with absolute value in this unit is how do we graph it? And I'm guessing most of you have never seen an absolute value graph before. So I want to start with the most basic absolute value equation is just y equals the absolute value of x. That's the most basic absolute value equation. I'm not adding anything, I'm not subtracting anything, I'm not multiplying, I'm not dividing. I just have my y, my equals, my absolute value, and an x. That's as simple as I can go. So I want to graph the simplest one first. And then we'll start transforming it. We'll start maybe moving it around or things like that. We'll see what happens. All right, so let's start basic. And if we don't know what a graph's supposed to look like, one of the easiest ways to graph is to make a table of values. So to get a table of values, I start with x values, substitute them in for the x in the equation. So we have absolute value. Instead of x, I have -2. And that will give me my y value. I put a value in for x, I get a value out for y. I make some ordered pairs, I can graph. So we just saw this one. What's the absolute value of -2? +2. So the ordered pair, we take the x that we put in, and we take the y we just found. So -2 on the x, +2 on the y. There's our first point. So the two things I circled up there, it's how I got my ordered pair. The -2 we put in for x, and then the y that we got out as an end result. Next up, same thing with -1. Absolute value of -1 is just 1. How far from 0 is -1? It's 1 space. So I put -1 in for x, and I got a 1 out for y. This is not just going to be a straight line, so don't stop there and just think, oh, I'll just draw a line here. If this were going to be just a line, we'd just have a y equals x. We wouldn't have absolute value bars. Absolute value is different. The next one up is 0. And sometimes people get stuck on this, like, but Miss Golly, I can't tell you how far from 0 0 is. It's nothing. You're right. It is. It's nothing away. It's 0. It's 0. So 0 0. We like that ordered pair. That one's easy to find. There it is. So far, all we're getting is a straight line. So I can't stop here. It's absolute value, so I know it's not just going to be a straight line. So let's put 1 in. Here's where we have to be careful. The absolute value of 1 is 1. Absolute value of 1 is 1. It's 1 space away from 0. So we go 1, 1. Looks like our graph's finally starting to take a different shape other than a straight line, and that's what we need. Let's do the same thing with 2. Absolute value of 2 is just 2. Notice all my y values, guys, they're all positive. Because when I take the absolute value, I get a positive result because it's a distance. So 2, 2 is right there. What kind of shape did we make? We made a V. We made a V. Are the two sides of the V straight? Yeah. The two sides of the V are straight. So we have a V shape. It's V-shaped. So when you go to graph absolute value, you know you need a V shape. If you try to graph absolute value and you come up with just a straight line, or maybe something that's a little curvier or things like that, if you don't get a V shape, you know you did something wrong. Another thing to kind of check out, take a look. We had a 1 on this side and a 1 on this side. A 2 for the y, a 2 for the y. They're matching up perfectly. If I were to draw an imaginary line down the middle of my graph, if I were to fold the graph in half on that line, the two sides would match up perfect. So this graph, besides being V-shaped, also has the property of symmetry. It's symmetric. If you've never heard of that word before, that's okay. It simply means if I fold this graph in half, if something's symmetric, if I fold it in half, the two sides match up perfect. Now, just a little technical language. We're not going to get super technical with things. But I know a lot of you are going to choose to take Algebra 2 at some point. When you choose to take Algebra 2, they like using more of the technical language at that level. So as we do things this year, I want to make sure you hear some of that vocab and that technical language. So when you hear it again later, you're like, oh yeah, Miss Golly said something about that. So that imaginary line, if you fold your graph in half on, that is called the axis of symmetry. It's something I'll keep talking about, just so you're familiar with. Just so you're familiar with. Another piece on here, again, I just want you to be familiar with, so we have a little bit of common language. That middle point right there, kind of where your graph changes directions, where the two halves of the V meet, the point in the middle, lots of different ways to describe it. That point is known as the vertex. Our graph makes a V. That middle point of the V, or the place where the V changes directions, V for vertex. That's how I remember it. Now, since we said the two sides are straight, one thing that's really familiar for us with straight lines is the idea of slope. Whenever we had a straight line, we could always find the slope. So let's check this out. If I start at 0, 0, I go up 1, right 1. Up 1, right 1. Up 1, right 1. We have a slope of 1. We have a slope of 1. Now, if I check out the other side, what do you think the slope on the other side is going to be? Negative 1. It's just going in the other direction. It's just going in the other direction. So this is, we didn't know how it was going to look, so we used a table to give us an idea of what the graph looked like. This is the most basic absolute value graph we can have. The slope on the right side is positive 1, slope on the left is negative 1. It's a V shape, it's symmetric. So let's try. Today I wanted to keep things as simple as I could. So we're going to start transforming this graph, so making changes to it, by multiplying to begin with. I think multiplying is one of the easiest things to do to this equation first. So there's a few different types of numbers we can multiply by. I'm going to go with a number larger than 1. So multiplying didn't move our graph anywhere. It made it skinnier and it changed the slope. That's all it did. Let's see if that holds true though. I want to do one more where we're multiplying by that bigger number, just to make sure that that's what's happening. So let's grab one more on this sheet. I'm going to multiply by 3 this time. I'm going to multiply by 3 this time. So we've got our 3 up front, absolute value of negative 2. 3 stays. Absolute value of negative 2 is 2. So 3 times 2 gives me 6. Now I want to give you guys a chance to try graphing this one. You fill in as much of the table as you need. You do as much of that table as you need to try to get this graph. And I'm going to freeze my screen up here. I'm going to fill my table out, fill my graph out. I want to give you a few minutes to try it. And now's a great time to ask. If you're like, Miss Golly, I'm not sure how you just got that 6. Now's a great time to ask, so that 6, where the heck does that come from? So I'm going to freeze my screen up here. I'm going to fill my table out on here. You do as much of the table as you need. So again, I'm just filling mine out up here. You try yours. Then just a minute, I'll do a little reveal here for you. I'm getting great questions though, guys, so keep those coming. Clarify what you need. Some of you have very little absolute value experience. Some of you have maybe worked with it a little more. Maybe you've even solved equations with it before, and we'll get to that a little later on. I'm going to go ahead and put my table up just so you can check yours. I do not expect at this time that you're finished with your table or you're finished with your graph. I don't expect that, but I want you to be able to check as you go. All right, so once you have your graph, then the question becomes, how is our graph different from the basic? On our last one, we talked about the slope. What's the slope of this one? What do we think? What's our slope? Slope is, what do we got there? Slope on the right side is 3. All right, so slope is 3 on right side. And is our graph getting skinnier yet, or what's happening with it? What do you think? Here's the original one. Here's the original one. Are we getting skinnier yet? Yeah. And some of you are like, Miss Golly, but it seems to be getting longer. It's not, guys. I can extend this graph out forever and ever and ever, too. So the lines really aren't getting any longer. We've got arrows on the ends. They go forever and ever and ever. So this graph, again, we're getting skinnier. Or more narrow, if you like that. So our first transformation we've done is we've multiplied our absolute value by a number bigger than 1. Whenever we did that, the number we multiplied by became our slope. Slope of 3 when we multiplied by 3. And then we saw our graph get skinnier. It went up a little bit faster. It got skinnier. That's when we multiplied by a number bigger than 1. So if multiplying by a number bigger than 1 made our graph skinnier, what do you guys think is going to happen? Let's go to the back side of this page. What do you think is going to happen when we multiply by a number? We're going to go between, we're still going to multiply, but we're going to go between 0 and 1. So something bigger than 0 but smaller than 1. So yep, that means a decimal or a fraction. Multiplying by a number bigger than 1. Multiplying by a number bigger than 1, our graph got skinnier, and that number we multiplied by became our slope. So let's see what happens. We're going to stick with multiplying. All day today it's just going to be multiply. We'll do some add and subtract stuff tomorrow. We're going to multiply by a number that's between 0 and 1. And I don't know, my table kind of disappeared here. Oh, now it's coming back. There we go. All right, so let's try this out. We're still going to multiply, but we're just going to use a half. We're multiplying by a half. It's not going to change anything we're doing. We're still going to have our 1/2. We still have an absolute value bar, and we still put a -2 in its place. That's all we're doing. So we still have to do the absolute value first. Don't let the fraction freak you out. We still have the 1/2. Absolute value of -2 is still 2. Don't let the fraction change what you just did on that last table. If you need to get the calculator out, that's fine. No big deal. We have 1/2 times 2. 1/2 of 2 is 1. So my ordered pair is -2, 1. So there's our first point. It's -2, 1. We have a 1/2, absolute value of -1. Again, shortcut this computation whenever you feel like you're ready. Show as much as you need, or as little, whatever. Now, I really wanted to make sure we saw some of these today, because I know for some of you, you might end up going back to the table on some questions, so I just wanted to refresh us. We can have fractions and decimals as part of ordered pairs. That's okay. I go -1 on the x, and then I just go up half of a box on the y. That's okay. Oh, that just changed on its own. Sorry, guys. That moved all on its own. There we go. Okay. Now, when we're at the 0, what's going to happen with 0? What's going to happen when I multiply with the 0? We're going to get a 0. Now, since I know fractions are not our most favorite thing in the whole world, let's try to get the rest of this table filled out and the rest of this graph without having to write out and scrunch in all that little computation stuff in that second column. We said our graph is symmetric. If we fold our graph in half on that imaginary axis of symmetry, the two sides should match. Well, the middle is also right here on our table. So if this one is a half here, what's this one going to be right below 0? It's also going to be a half. If the one up here is a 1, the one down here will be a 1. If we look at it on the graph, this point is 1 away from the middle, so there's going to be a point right across from it that's 1 away from the middle. This point is 2 away from the middle, so there's going to be one on this side, 2 away from the middle. So you could look at the table and use that symmetric property to get the table faster. Or if you've already graphed half of it, use that symmetric property to get the other half of the graph faster. Okay, I know you guys are like, yeah, Miss Scott, let's get these shortcuts coming, because writing all that stuff out, and these are some of the simple ones, let's get the shortcuts coming. That's what I'm trying to get for you. So now if we talk about the differences, what's happening with this graph? What do you guys think? On our other graphs, we kept talking slope. What's the slope of this side? It's 1/2. I go up 1 and right 2. Up 1, right 2. The slope is a half. Slope is 1/2. And I like to keep putting on the right, because the slope on the left is going to be the negative of that. It's going to be the opposite sign. All right, and when we multiplied by 2 and we multiplied by 3, our graph got skinnier. What's happening here? What's happening here? Are we getting skinnier? Or are we kind of flattening out more? What's happening? We're widening, yeah. We're getting wider. We're getting wider. So that number that we keep multiplying by, multiply by 1/2, we had a slope of a 1/2. Multiplied by 2, we had a slope of 2. Multiplied by 3, we had a slope of 3. Let's see if we can make this graph with the 1/3, because I know how much you guys love doing computation with fractions. Let's see if we can make the 1/3 one go faster. All right, so let's talk. Every question we've had slope. Slope, slope, slope. So if I have 1/3 x, well, 1/3 absolute value of x, what's our slope going to be, you think? What do you think? 2 times the absolute value of x, slope was 2. 3 times the absolute value of x, slope was 3. 1/2 times the absolute value of x, slope was 1/2. Trying to make this less work for you guys. What's our slope going to be now? What do you think? Okay, let's fill out the table then. Here we go. Trying to help you with shortcuts, folks. All right, absolute value of -3. A third of 3 is 1. Sure you guys aren't sure what the slope might be on this? I just heard somebody say, hey, let's try a third. Yeah, I'm game to try that instead of filling out this whole entire table. Let's see what happens. So I did the first row of the table. I got -3, 1. Okay. What do you think is going to happen when we put 0 in? What have we been getting? We've been getting 0. And we said we're hoping the slope is 1/3. So I'm going to go up 1, and I'm going to go right 3. We think the slope is 1/3. That's what we think. So this is the point. That's the ordered pair 3, 1. So here's where my x is 3. Let's see if we get a 1 out. Here's where my x is 3. And lo and behold, we do the work, and we do get 3, 1. Our slope was 1/3. Our slope was 1/3. This side is just the opposite sign of that. Not the opposite, just the opposite sign. The slope on the left will just be -1/3. I talk about the slope on the right because the slope of 1/3 on the right matches the number that we multiply by. It matches the number we multiply by. So slope 1/3 on the right. And again, we see our graph getting even wider. It's getting wider. So far we've seen when we multiply by a number, that number gives us our slope on the right side of the graph. That number gives us our slope on the right side. Then we can use that right side to find our left side slope. Or, if you don't want to worry about the slope on the left, just make sure you're matching up your points. If you get a point on the right, you're going to have a point that matches exactly with it over on the left. So you can use that symmetric property too if you're like, Miss Guy, I don't want to have to deal with another slope. You don't have to. So we've multiplied by numbers bigger than 1. We've multiplied by those fractions between 0 and 1. The only type of number we have left to multiply by is a negative. So what happens if that number in front is negative? And I wanted to make sure we saw this. We're multiplying by a negative. What number is really there though? A negative what? 1. There's really a -1 there. Instead of just saying there's a negative sign there, let's look at it as we're multiplying by a -1. So let's see what happens when we multiply by -1. For this one, I'm not real sure. So I'm going to fill out the first little bit of the table to see what's happening. So -1, absolute value of -2. Same pattern as before. The -1 stays. Absolute value of -2 is 2. The end result of this is a -2 because I'm multiplying by -1. My absolute value was still +2. Absolute value was still +2. Then I multiplied by -1. So -2, -2. Do the same thing. We put a -1 in those absolute value bars. The -1 becomes positive. Again, the only reason our final result is negative It's because there's a negative 1 I'm multiplying by. What's going to happen when I have that 0 in there? It's going to be 0. So we got a 0, 0 right there. So it looks like we have half of our graph. Let's get one more point to see what's going on here. So negative 1, absolute value of 1, guys, is 1. Don't be trying to switch the sign. So 1, negative 1. Then if we stick with our pattern, we should have a point right there to finish her off, to keep my graph symmetric. So what did multiplying by the negative do? What happened to our v? It went upside down. We went upside down. It went upside down. What does it mean for our slope? What's the slope on my right side now? Now we're going down 1, right 1. Down 1, right 1. If I go down and then right, that's a negative 1. So sticking with what we've been seeing, that number that we multiply by, we multiplied by negative 1. Look what our slope was on the right side. That number that we're multiplying by is our slope on the right side. So let's try. The last one we're going to graph today is on the second sheet. And let's try to do it as much as we can without having to bring in the table. Let's take everything we've done today and let's try to do this without the table. Where was our vertex point at today every time? 0, 0. That vertex point, that's that middle point. That's the pointy part of the V, if you will, or where the V changes directions. So 0, 0. That's when our vertex has been for every graph so far. Our graph hasn't moved today. It hasn't moved left, right, up, or down. So that middle point's been right at 0, 0. What's the slope of my right side going to be? What do you think? Slope on the right is? What are we multiplying by? We're multiplying by negative 2. So that means my slope on the right side is going to be negative 2. But now here's the catch though. I know when we've had a negative slope before, we've had the options of up and left and down and right. If I go up and left, am I on the right side of my graph? If I go up and left, am I on the right side? No. That number is my slope, but I have to stay on the right side. Down and right. Down and right. So we have half our graph. To get the other half, you have two options. Option 1, think about our imaginary vertical line, that axis of symmetry, and reflect your points over it. So if this point is 1 away from the middle, there's a point on the other side, 1 away from the middle. If this point is 1, 2 from the middle, I have a point on the other side that's 1, 2 away from the middle. Your other option is if the slope on this side is negative 2, the slope on this side is positive 2. You might be like, Miss Scally, that's not positive 2 because we didn't go up and right. Well, we can't go up and right because we have to stay on the left side of the graph. So we have to go down and we have to go left. For me, I honestly think the easy way is to use the slope on the right and then just reflect my points over that middle. But that's me though. We will get some practice with this tomorrow. We're going to start moving the graph left and right tomorrow also, or up and down, I don't remember which. We're going to move it tomorrow. So when you go to graph, we're going to still make some tables tomorrow just to get an idea of how things look. We're going to start adding and subtracting. But keep in mind, we can use the slope on the right. Your choice of how you want to get that left side. Use the opposite of the slope, or do you want to just reflect points over? It's your choice. So let's pull this all together. And then we'll get a little bit of practice with this tomorrow. Let's pull it all together. I just used a generic capital A. It's in front of the absolute value bars. That's where our number we've been multiplying by has been today. We had a 2, a 3, a 1/2, a 1/3, a -1, and a -2. So that A is the slope on the right side. It gives us the right part of our V. It's always the right side. So if you have to move up and right to get that, or maybe you have to move down and right if it's a negative slope, you have to move right to get that slope. When our A value was greater than 1, again, I want to stick with some technical language here. A value greater than 1, it's actually called a stretch. A stretch. You might be thinking, Miss Golly, but stretch though, why would it be called a stretch if it gets skinnier? Because if you take your arms up above your head like our V shape and you try to reach up and stretch, you're going to get skinnier to stretch up higher. So number greater than 1, we're going to get skinnier. The technical speak for that is a stretch. When our value was between 0 and 1, so when we had those fractions, the 1/2 and the 1/3, it's actually called a compression or a shrink, whichever one you like best. And that's when we got wider. So if we were to compress you, so take your head, take your feet, and try to smash them together, you have nowhere to go but out. So you're going to get wider if you're being compressed. Last but not least, that negative sign, technical speak for it, is a reflection. What we noticed is our graph goes upside down. That's what we saw happen. Our graph went upside down. So what we're going to look at tomorrow, I know there's some practice questions on here. So tomorrow when we start, we're going to do just a couple of the practice ones where we're just multiplying. And then we're going to take a look at what starts happening when we start doing some adding and some subtracting. Okay, that's what we're going to look at tomorrow.